let's see if we could solve this differential equation. First, we're going to distribute this stuff into this parentheses. So we're going to have 2 divided by e to the 3x dy over dx plus 3 divided by e to the 3x y equals 8x. Now we can sort of see that there is a term in front of our differential here. So we'll go ahead and multiply. Well, really, we're going to divide this term out. So we're going to get 2 over 3x. But that's the same thing as kind of multiplying this whole thing by e to the 3x over 2, isn't it? So we'll go ahead and do that. And we'll see that it would cancel pretty nicely over here. So we get like a dy over dx. And then over here, it would sort of cancel pretty nice there too. And we get plus 3 over 2y. But then on this right side, it would look like 4x e to the 3x. Now we're going to want to find the integrating factor. So we're going to use the constant here, the coefficient there. We're going to call that coefficient p. And we know that's 3 over 2. And what we can do is we can put that to the power of e here. And then we're going to want to integrate that over dx, which of course is just going to leave us with 3x over 2 on top. We could use that to multiply it across, 1, 2, 3. We're going to get something like e 3x over 2, and then we have dy over dx plus 3 over 2 e to the 3x over 2 y, which equals 4x e to the 3x times e to the 3x over 2. We can convert this into halves, and we can see we could just add this stuff on the right, 9x over 2, and on the left, well, we have this whole thing which we have to realize it's going to be the product rule based off of d over dx of e to the 3x over 2, which is our thing over here, times the y. And this clearly would just give us both of those terms if we try to differentiate that out over there. And now we're going to try to integrate this on both sides by dx. That will just get rid of all the integration over here and derivative stuff. So e 3x over 2y gives us, we have to solve this integral here. In order to solve this one, let's just set it up with the di method. And we have sort of like a plus, minus, plus. We're going to go 4x, 4, and then it hits 0 there. We have e to the 9x over 2 beginning. When we take the integral of that, it'll become e to 9x over 2. We also have to divide this by the derivative of what's up here, which is just simply going to be like 9 over 2. We'll put the 2 on top. And over here, we can do the same thing at 9x over 2. But this time it'll become 4 over 81. Now we can finish off this little integral. We'll call that 8x over 9 e to the 9x over 2 minus 16 over 81 e to the 9x over 2 plus c. So now we could basically say that's actually technically our answer. I mean, we could divide out that 3x over 2, but we'll just kind of get kind of a big mess. So, here we go.